So we start off, hopefully these are the more basic ones. So this is your collinear and then coplanar points. Everybody okay on these? Yeah. Then comes the line and the plane that's shown. So remember, a line, you have to either put the word line or you have to put the arrows over the top to show that it's a line. It can't be just the two letters. The plane can be at 3 of any of those points, but it has to be they have to be non-collinear. So it doesn't matter what you pick this time because no 3 points are on the same line. But you could kind of use any of those. If this was multiple choice, obviously you'd know which one to pick. Number 4, the points C, G, and H are not collinear because they don't lie on the same line. 5 is yes, and then name the line which they lie on. You can call it any of those, MN, NO, or MO. You don't have to list all 3. And 6, name the plane represented by the front of the box. That would be BCGH or BCFG or any combination of those 3 letters. Of those 4 letters, sorry. Okay, then comes planes that can contain point A, and there's 3 of them there. The ray in the figure, remember the ray has to have the arrow over which one has the arrow, so B gets the arrow, or if you write it as ray AB, the B it would be the one where the arrow is. 9, what's the name of the ray that's opposite BD? Remember, opposite rays share the same endpoint but point in the opposite direction. And 10, what are the names of the segments in the figure? And there's BC, AB, and AC. Segments either have the line over them or just would say, like it could just say BC. That's the same thing as segment BC. Those two mean the same thing. So if you don't put a line over it, you're implying segment. Questions on those? Okay, 11, name the intersection of plane ACG and plane BCG. So it's kind of hard because there's no diagram there and you don't really know what that 4th point is. But if you have overlapping points like C and G, that's obviously where those would intersect. And then remember that the intersection of a plane has to be a line. Yep. Because they intersect, right? It's the top side and actually this should be line ST. 13, name a 4th point in plane WXV, and that's U. This is your kind of like imaginary diagonal plane. Even though it's not there, it doesn't mean it doesn't exist. It does still exist. You just had to connect it. So once you got the WX and then the V here, you knew you were going that kind of diagonal plane, so that would have been this. 14, what plane contains CG and H? It would be CDGH or any 3 letters of that combination or that front plane. 15 started the coordinates. So now you're trying to find the length. If you just count or you do the big one minus a little one or the absolute value of their difference, either way it should be 13. 16 was your angle addition postulate, segment addition postulate, which is 15. 18, also your segment addition postulate, you had to add the 2 parts together, set it equal to 23, and X should have been 10, EF should have been 8, because you got to plug it back in, and then FG should be 15. You can either plug it back in, or you could subtract it from the 23, and you should get the same answer, so it's a good way to check it. 20 says what segment is congruent to AC, so first you had to figure out that AC was 6, and then you had to figure out which other one was 6, which would be BE. 21, definition of a midpoint is that it would cut those into 2 congruent parts. So 8x minus 10 would equal 150. Solve for x, you get 20. And then it said, again, be careful what it's asking for, RZ and RT in addition to x. So you had to take it and plug it back in. And RZ should be 1/2 of RT. So when you find those answers, you should be able to multiply the 150 by 2 to get to the 300. Questions on those? Mm-hmm. So RT's the whole thing, right?
Yeah. Oh, we have to figure that out too.
Yeah. I mean, good news is it's multiple choice, so hopefully you should catch that kind of a thing. But just be really careful.
The whole thing?
Minus the proofs. All right, 22 was, again, midpoint. So I had to figure out the middle between A and E. If you add -6 and 8 divided by 2, you're like finding its average. That's 1. And the point, that 1 is the coordinate, D is the point. That matches it. 24 says, judging by appearance, name an acute angle, an obtuse angle, and a right angle. There's more than one answer for acute. Angle VUY, angle V, and angle X all appear to be acute. Obtuse would be angle W, and right appears to be angle Y. And notice it says appears because obviously that's not exact. To be a right angle, you'd have to have it marked, and sometimes they're not drawn to scale. 25 is using this little protractor image. So angle FBG is 35, which is acute, and angle ABC is 180, which is straight. 26, angle GDF would be congruent to EDF. 27, angle GDF is 54, then EDF would be 54. 28 is your angle addition postulate. So I take the two small parts, add them up, and set them equal to that 85, and you should get X is 15. And then it asks for the degree measure of BOC and AOB. So you take that 15, you plug them back in. BOC is 40, AOB is 45. When you add those together, you should get the large angle, which it gave you was 85. So it's a good way to check it. 29, angle FEG should have been 61. And angle HEG is 119. Those are a linear pair, so they have to add up to 180. No. No. One, you shouldn't need it, but two, no. Questions on those? Everybody still good, right? Okay. 30, if EOF is 26 and FOG is 38, then the big angle would be 64, angle addition postulate. 31, supplementary forms a linear pair, so you could either say EOD or you could say COA. 32, complements add up to 90 degrees, so this would be angle COD. 33, vertical angle, angle FGI. Remember, those are the ones that if you extend them, the sides become the opposite. The sides of one angle, opposite rays, would become the sides of the other angle. Adjacent would be next to, without overlapping, so angle DGF or angle EGH. 35, supplementary 180, complementary 90. 36, like we just said, two angles whose sides are opposite rays are called vertical angles. Two coplanar angles with a common side and common vertex and no common interior, which means it doesn't overlap. Would be adjacent angles. So you will get some vocab questions kind of mixed in with your figures and stuff. Okay, 37, so you could see information like this. It says, what can you conclude from the information in the diagram? And C is the only one where all of those parts were right. LM equals NM, PN equals PO, and angle PNO and LMN are vertical angles. 38, the complement would be 37. 39, I would add them and set them equal to 90. X is 46. And then it asks for the measure of each angle, so I have to plug that 46 back in and I get 48 and 42. If they're complementary, then when you add them together, they should equal 90. 40 says they're a linear pair. If they're a linear pair, they're supplementary, so you add it up, set it equal to 180. You get X equals 59. And it said find the measure of each angle, so you plug that 59 back in, and you get 44 and 136. And if they're supplementary, then when you add them together, they should equal 180. Still good? 43, this says that it bisects. So if it bisects, it cuts this into two equal parts. I set 6x minus 20 equal to 2x plus 36. I get x equals 14. And then it says solve for x and angle LMN. So I take the angle, I plug it back in. LMN is the big angle. So you can plug it back into both and add them together. You can plug it back into one and double it. Either way, you should get 128. 44 says bisects again, but this time instead of giving you the two small parts, it gives you one of the angles and then the whole angle. So 2 times the smaller angle is going to equal the big angle, which is where this comes from. X ends up being 28. Plug it back in to get NMO, and NMO is the same as LMO, so you can plug it back in there and you should get 59. 46, find the midpoint. Find the midpoint. So the midpoint formula, this is the first time you've seen a formula that you need to know, which is the midpoint, x1 plus x2 over 2, and then y1 plus y2 over 2. That should be 2, 0. Second formula you need to know is distance, square root of x2 minus x1 squared plus y2 minus y1 squared. 49, this is where you were given one endpoint and the midpoint, so you had to split these, and you would have gotten 6, 3. 51 is distance. So this said to round to the nearest tenth. If it says keep it exact, you would leave it as the square root of 61 and see if it could be simplified. If it says to round to the nearest tenth, you're approximating. So I know 64 is in between the two perfect squares, which are 49 and 64, which is 7 and 8, and it's closer to 64. So for my answer choices, I should be able to eliminate the ones that don't make sense. 52, Noam walks from school walking 8 blocks north, so that's like straight up, and then turns 6 blocks east, that's 6 blocks to the right. How much shorter would his walk be if there were a direct path? So you find the distance, use the distance formula to find the length of this side, which is the hypotenuse of that triangle, and you would get that it's 10 miles across. So because it says how much shorter would his walk be, his current walk was 8 plus 6, which is 14. If he took that shortcut, it'd be 10, so you would do the 14 minus the 10 to get 4 blocks shorter. 53 travels from the mall through the city center to the park. So that's this first one. It goes 4 miles east and then 5 miles north. The other one goes 4 miles west and 2 miles south. So you can make coordinate points from those. The mall would be 4, 5, and the park would be -4, -2. And then to find the distance between them, I would just use the distance formula with those 2 coordinate points. And again, if it said to round to the nearest tenth, we're going to approximate. If it doesn't, I would keep it as square root 113. All right, 56 says find the perimeter of the triangle with the vertices. So the vertical and the horizontal side, the 8 and the 6, we can simply count those. But to find the hypotenuse of this one, we had to use either the distance formula, or if you use the Pythagorean theorem, that works here too, okay? And you would find that that missing side is 10, and then the perimeter, you add up the 3 sides. All right, 66 is based on the pattern. The next 2 terms would be 33 and 39. 67 based on the pattern. The 9 stayed the same, but everyone in the bottom got multiplied by 5. So you get 9 over 3,125 and 9 over 15,625. The 77 said to identify the hypotenuse and the conclusion, hypothesis and the conclusion. So it's after the word if is your hypothesis, 2 lines intersect at a right angle, and after the word then is your conclusion, the 2 lines are perpendicular. 79, write the statement as a conditional if-then form. If the figure is a triangle, then it has 3 sides. It doesn't have to be exactly that, okay, but something along those lines. Again, keep in mind this would be multiple choice, so you should be able to figure it out from your choices. 81, what's the converse? Remember the converse, we switch the order. So if a point's the 4th quadrant, then its coordinates are negative, you switch those. If a point has negative coordinates, then it's in the 4th quadrant. 82, write the converse, so switch the order. If x squared equals 49, then x is 7. That's false because x could also be -7. 83, this would be the converse would be if 2 lines do not intersect, then they're parallel. That's false because they could also be skew. So the counterexample would be skew. 84, when you combine them with the if and only if, it's called a biconditional statement, which is what you did in 85. An angle is a right angle if and only if its measure is 90, or an angle is 90 degrees if and only if it's a right angle. 86, 2 conditional statements if you break this apart. If I drink juice, then it's breakfast time. If it's breakfast time, then I drink juice. Again, it'd be multiple choice, so if your wording is a little off, it's not a big deal. 91, if the law of detachment says if the first part happens, then you assume the second part. So because they say x equals 7, you go directly, what you can conclude is that 7x minus 2 equals 47. Law of detachment says, again, if 2 angles are complementary, then the sum of their measures is 90 degrees. Law of syllogism is the if and then. So if you exercise regularly, then you have a healthy body. If you have a healthy body, then you have more energy. The law of syllogism joins the first and the last. If you exercise regularly, then you have more energy, the part that doesn't repeat. 96 was both law of detachment and law of syllogism put together. If it's Friday night, then he's wearing his school colors. Questions on those? Okay, that was chapter 2, right? So and then we got our justifications. So you'll see something like this where part of it's filled in, and then you'll see a complete open proof. So this one where you've got parts missing, this is angle addition postulate and an addition property of equality. 99 was your bisector again. You had to set them, you did 2 times 3x plus 36 equals 7x, solve for x, and then plug it back in. Number 100, 101, 102, and 103 are dealing with your property. So 100 is symmetric, 101, if it's transitive, then if A, then B, and B, then C, then A, then C. So you join the first and the last. Multiplication means I'm going to multiply the 9 on both sides. Substitution means I'm going to take that -5 and plug it in for y. Still good? Okay, 104 and 105 still properties. 104 is symmetric property of congruence, and 105 transitive property of congruence. 106, this is your algebraic proof. So it's given, then substitution, addition property of equality, division property of equality, and symmetric property of equality. 108, these are vertical angles. God bless you. Set them equal to each other, and I get x equals 16. 110, also vertical angles. If 2 is 30, then 4 is the same, which would also be 30. Remember that if you're using the theorem, and this is something a lot of you make the mistake on your proof, if you're using the theorem in your proof, it has to be vertical angles theorem. If I'm saying angle 2 equals angle 4, that is not vertical angles. That is not definition of vertical angles. That is vertical angles theorem, which is VAT. Okay? You have to use the theorem. You don't want to lose points on something like that. 111, there's 2 things going on. You've got vertical angles, 7x plus 7 equals 112. And then you've got a linear pair, 4y plus 112 equals 180. $113, now you're talking parallel. They have to be in the same plane. So this would be J, K, K, P, N, P, and J, N. Perpendicular also have to intersect, but they have to intersect at a right angle. K, L, J, M, N, R, P, Q. That was this beginning of chapter 3. Then comes your special angles, alternate interior, alternate exterior, corresponding, same side interior, all that stuff, or consecutive interior. So you want to be able to identify what kind they are from the diagram. And 4 and 5, these would be alternate interior. So they could match any of the angles on that diagram and ask you to identify their relationship. If they are parallel, then came all the theorems, right? If they're parallel, which are the kind of angles that are congruent? There's 3 of them. Which special pair of angles are congruent if the lines are parallel? Alternate interior, alternate exterior, corresponding. And what's the last special pair? Same side interior, consecutive interior, and those are supplementary, right? Same side interior or consecutive interior. So that we got to use for 119 and 120. Linear pairs, vertical angles, and those special angles. But in order to do those lines have to be parallel. Continuing on with those, you had corresponding angles and consecutive interior in 122. In 123, you've got consecutive interior, which means they're supplementary. $125, again, parallel lines. So you've got corresponding angles here and here. Those would be equal. And then these 3 add up to 180. So once you found the x, you can plug it back in. 126 was the converse start. So if corresponding are congruent, if alternate interior are congruent, if alternate exterior are congruent, then the lines are parallel. And if consecutive interior are supplementary, then the lines are parallel. So 3 and 6 were the alternate interior. And remember, we used the converse there. in order to prove that they're congruent. In order to prove they're parallel. 127, okay, what value would make them parallel if they would be equal to each other? So x would have to be 13. 129 would be alternate interior. Those would also have to be equal to each other. 137, in the triangle, they should all up to 180. So k is 72. 132, you had to use that information and linear pairs to find them. 133 was your alternate exterior angle, which said that, not alternate exterior, sorry, exterior angle sum theorem, which said that the exterior angle is equal to the sum of the non-adjacent or remote interior angles, the ones that are not next to it. 135, you had to use vertical angles, and then this triangle sum theorem, which says they're 180. 136, if it has angles in the measures of the ratios 8 to 6 to 4, then we would say 8 times x plus 6 times x plus 4 times x equals 180. And you get x is 10. And then if it wants the smallest measure, you have to multiply them each by 10. The smallest one would have been 4 times 10, which is 40. Now we get into slope. So slope is rise over run, y2 minus y1 over x2 minus x1, which is 9/7 here. You can either count it or you can use the slope formula. 142, again slope, but then it asks for the slope intercept form of the given line. Remember, slope intercept form is y equals mx plus b. This is point slope form. Pay attention to the instructions because some of them will tell you to put it in point slope and some of them will tell you to put it in slope intercept. And if you put it in the wrong form, even if the equation's right, it's wrong. And multiple choice will get you there. 143, if it's a vertical line, it's an x equals. 144, if it's a horizontal line, it's a y equals. 145, you have to compare the slopes. If they're parallel, they are the same. In this case, they are not the same, which means they are not parallel. If they are perpendicular, then they're opposite reciprocals of each other, or the product is -1. 146 asked for it to be in point slope, so I left it in point slope. 148, same thing. If it had asked you to put it in slope intercept, then you would keep going there. Y minus 1 equals 5x plus 30, add the 1, and y would equal 5x plus 31. So be careful and pay attention to the directions because I'm telling you right now the questions will tell you what format to put it in. And if it says slope intercept and you do this, you get that whole question wrong because it's multiple choice. There's no partial credit on that stuff. If it says to put it in point slope and you put it in this format, then you get the whole question wrong. Okay, 148, now it's perpendicular, so you have to use the opposite reciprocal, which is -1/2, plug it in. 149, now we're talking about congruent polygons, so you have to match up the letters. Same thing for 150, make sure you're putting the letters in the right order. Now it's congruent triangles. 151, if Q, S, and TV are congruent, you set them equal to each other and solve, and then make sure you plug back in to get Q, S, and TV. 154, still congruent triangles, so the sides would match up and the angles would match up. 155, it asks how you would, what would be your reason for those. Those would both be given based on the diagram. 156, so if you want to put a little like star or something by 156, okay, here's an example of what a proof could look like where you have to fill in part of it. So there's two proofs that are your open-ended component. One is partially filled in like this, and one is completely open, okay, which comes from your congruent triangles proofs. So if you need to study the proof, you go back to chapter 4. In chapter 4, we did lots of proof practice on proving triangles were congruent. So remember that there's angle, side, angle, side, angle, side, 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 hypotenuse, leg, and angle, angle, side. Those are the 5 ways to prove triangles are congruent, okay? Your proof will involve one of those. I'm telling you right now, you've got to know them, okay? And then we also went one step further and said if the triangles are congruent, then all their parts are congruent. What's that called? So close. Cpctc. So if I prove the triangles are congruent and then I prove an additional step, like if I look at 156 and I said angle TSU is congruent to angle RTS, then the reason would be Cpctc. So be prepared for proofs on congruent triangles, which again, chapter 4, we did a lot of proof practice. We did class kick that had like 5 examples if you want to make sure that hopefully you exported that. If not, we can look at it. And then also like within your chapter, we did lots of proof practice on that stuff. So if you want to prepare for your proof, go back to chapter 4. Good morning. Hi. 157 is which one is included. That's angle N. 158, what other information do you need to prove? Same thing for 158, you would need to know the angles, the additional angles are congruent. 159, there's also going to be questions like this where it's just a simple yes or no, and if it's a yes, what? So yes, side, 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 or side, angle, side on that one. 160, the two that are congruent are F, G, H, and C, B, A. 161, there are two. It says what would you need to know to prove angle side angle, and then which one side angle side. So for angle side angle, you need to know another pair of angles. For side angle side, you need to know another pair of sides. 162, these the DF and DF would be reflexive, and then the triangles would be congruent because of angle side angle. There's no such thing as angle 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 congruence. Here's another good practice for proof in 163. 164 was your base angles. Once the sides are the same, the angles are congruent. Yep. So this is an isosceles triangle, and I know that because the two sides are marked the same, right? So if the two sides are marked the same, then the angles opposite them are also equal to each other, which means if the left corner is x, so is the right corner. And then the sum of those three angles have to be 180. So I can say x plus 38 has to equal 180. Or 2x plus 38 has to equal 180. So 2x would equal 142, and x is 71. Good. Mm-hmm. 165, this is still the base angles theorem. 167, you use the base angles theorem to solve for x.
Can you go over 164?
Okay, this one, if the sides are congruent, then the angles opposite them are congruent again. So this would be, 180 would be for here, and it'd also be for here. So you have to do 180 minus 8x plus 180 minus 8x plus the angle at the top equals 180. So be careful and make sure you're doubling the right one. .169 is talking about the isosceles triangle. The legs are the ones that are congruent. So if you set those equal to each other, x is 3. And then it says what's the length of the base, so you plug it back in. 170 is kind of tricky because you have one big triangle, which is an isosceles triangle, and this one. So if this is congruent to this, then these two angles are congruent to each other. So I can add those together and then subtract it from 180 to get this big angle up here. But y is half that angle, so you have to divide it by 2 to get that 44. And then you can use this left triangle, 46, 44, subtract it from 180, and you get that the last one is 90. 147 is yes, this would be a hypotenuse leg. Did I say 147? 174. 176, there's all that information that you could prove. Either these two sides, this one is congruent to this one, or this one is congruent to this one, or this to this, or this and this to this. So this, again, multiple choice, you'd be able to eliminate. You'd only see one of those options. Just be careful. 177, what common angle do they share? And that's angle C. 179 is your midpoint, or your mid-segment. So remember, the mid-segment hits the midpoints of two sides. It's half the length of the third side, and it's parallel to it, which tells you that AC here would be 34 because it's double the 17. Here, I'd say 2 times this side equals this side, and I get x equals 8. Here, x would equal double the 35, which is 70. So all of those are mid-segments. Then we got into angle bisectors, perpendicular bisectors, altitudes, all that stuff. Remember, angle bisectors are equidistant from the sides of the angle, so these two are congruent. If these two are congruent and the right angle is there, then these two are congruent. Okay, this is where your other vocab is going to come from. So again, make a note of it. This is your altitudes, your angle bisectors, your medians, and your perpendicular bisectors. You need to know what they are. You need to know what their point of concurrency is. And you need to know their theorems. And where they meet, right? So altitudes meet, well, we started with perpendicular bisectors, so let's go in the order we started with. Perpendicular bisectors meet at the point called the circumcenter. And these meet in, on, and out. In if it's acute, on if it's right, out if it's obtuse. Then we went to angle bisectors, and these are called in-center. And they meet always inside. Medians meet at a point called the centroid. And these are always in. And altitudes meet at a point called the orthocenter. And these are in, on, out. In for acute, on for right, out for obtuse. And then all of them had a theorem that went with it, except for the altitudes. Okay, perpendicular bisectors were equidistant from the vertices. Medians were the 2/3 rule. And angle bisectors were equidistant from the sides. So you might see an always, sometimes never question, like the perpendicular bisectors blank meet outside the triangle. That would be in, did I say perpendicular bisectors? Perpendicular bisectors would be sometimes. Okay, if I had said angle bisectors meet blank inside, it's always. If I said angle bisectors blank meet outside, it's never. Okay, you've got to know the vocab on that stuff. So the vocab questions, or the theorem-based questions where it's words, are going to come from like this chapter, and then the postulates in chapter 1, like 2 points form a line, 3 non-collinear points form a plane. All that stuff could be vocab type of questions. So 190 was the circumcenters, which is the perpendicular bisectors. They meet at the midpoint of the hypotenuse. So you had to find the midpoint there. If it had said orthocenter, those meet at the right angle. Questions on those? Again, a lot of vocab questions on that stuff. Be careful. All right, where's the circumcenter? This is what we just talked about. Circumcenter is located inside, on, or outside. 194 is the medians. This is your, if it's the median, it hits the midpoint of the side, so those would be 2 congruent parts. 195 is the centroid. The centroid is your median. That's the 2/3 rule. 196, if it's on the median, then those two would be equal to each other. No, sorry, it gave you AD, so you had to draw this one. AD, and it gave you DM, so 2 times DM would equal AD. 197 said name a median. So be prepared to have this word be altitude or perpendicular bisector or angle bisector, and you'd have to be able to identify it from your graph, from your figure. 198 is what's that? What's that? That's called an altitude. And then 199, now you're talking triangle inequality. So remember, the largest side is opposite the longest. The longest side is opposite the largest angle. Smallest opposite the smallest. Okay. 200 is that the third side must be greater than the difference, but less than the sum. And then everything underneath it was from your proportional. So this is all from similar triangles on the left-hand side. Remember that there's angle similarity. There's side angle similarity. And there's angle side angle similarity. Yep.
Can you explain number 1 for the...
Yeah, so these were all your proportions. So this all came from, what was the last one we just did? 6-5, right? Yeah, all of this is from 6-5. So if there's parallel lines inside your triangle, which is this, then it cuts these segments into proportional segments. So I can say 9 to x equals 12 over 136. I could say 12 over 9 equals 36 over x. So you can go top to bottom, left to right on those. And then the second one was the angle bisectors. Again, divides these into proportional segments. So I could say 16 to 8 equals x to 10, or I could say 16 to x equals 8 to 10. And then the third one was if there's 3 parallel lines intersecting 2 transversals, and these are also proportional. So I could say 28 to 8 equals x to 12, or I could say 28 to x equals 8 to 12. Okay, you can put them in all the different kinds of order. Questions on any of this stuff? So before I see you again, you need to know this packet well. You need to know how to do every question in this packet. If there's something you have a question on, I kind of just went through the whole thing. Feel free to watch this video if you get stuck. But also practice all the Quizlets. Okay, so there's a Quizlet on every single module. Use them. I will combine them all into one, but if you'd prefer them separated out, they'll stay separated out on the module. Okay, but I will add a link on the midterm review module. For a combined set of all of it.